So Europe's space program, it seems like it's really stepping up its game, reaching a new level of capability.
Uh-huh. There's definitely a lot of buzz.
Yeah, and we've been looking at some sources trying to figure out exactly what this means, for the future of spaceflight.
And the big news, the real core of this, is that successful test firing they just had. The P-160C solid rocket motor down in French Guiana.
Right, the P-160C. That wasn't just any old test, was it?
No, not at all.
Yeah.
It's a pretty big deal for the kind of power European rockets will have going forward.
Okay, so we've got info here on that test, obviously, but also on the rockets it's designed for Ariane 6 and Vega.
Mm-hmm.
And we even found a resource for you, the listener, if you want to learn more about space stuff in general.
Oh, cool.
Yeah. So for this deep dive, our mission, let's say, is to really understand the significance of this P-160C test. What does it actually unlock for Europe's access to space?
Well, that qualification firing, April 24th of the BE facility, that was the moment. It basically confirmed the motor meets all the tough standards. It's ready.
Ready for action. And this P-160C, it's not something they just picked up, right? It's a custom job, a big collaboration.
Exactly. It's come out of Ariane Group and Avio working together.
Okay.
Through their joint company, Europropulsion. And what's also really key here is that the whole thing was managed and funded by ESA, the European Space Agency.
ESA's fingerprints are all over this then.
Yeah.
A proper pan-European effort, and it builds on previous motors, like the P-120C.
Precisely. Think of the P-160C as the next step up from the P-120C. And here's where it gets really interesting technically.
Right.
It's one of the biggest solid rocket motors ever made from just a single piece of carbon fiber.
Wow, hang on. A single piece for something that big and powerful.
Yep. It's a serious bit of engineering. Think about the forces involved during launch.
So what's the advantage? Is it about making it stronger or lighter or...
Both, really. Using a single piece gets rid of potential weak points, gives it amazing structural strength, but also helps keep the weight down. And that's always critical in rocketry.
Makes sense.
And the main upgrade, the big stat, is the size. It's a full meter longer than the P-120C.
A whole meter?
Yeah, and that means it holds an extra 14 tons of solid propellant.
14 tons more fuel. Okay, so that translates pretty directly into more power, I guess.
You got it. More propellant means more thrust, longer burn time potentially. Basically, a major boost in performance for the launchers.
Right, getting bigger things up there or getting things further out.
Exactly. And importantly, they designed it so it slots right in. It maintains compatibility with the existing Ariane 6 core stage structures.
So they don't need to completely rebuild a rocket to use it? That's smart. Saves time and money.
Definitely. Makes the transition smoother. And speaking of that, the industry side has been gearing up too.
How so?
Well, Ariane Group, Avio, and, their whole supply chain, they've been upgrading their production facilities.
To build these bigger motors.
Yeah, to handle manufacturing the P-160C reliably and at the scale needed for future flights, while also keeping the P-120C production going, because that's still needed too.
Okay, so we've got this much more powerful motor, the P-160C.
Yeah.
How's it actually going to, upgrade the rockets, Ariane 6 and Vega?
Right. This is where you see the payoff. It's designed to enhance both of those launch systems, which are vital for Europe. Maybe let's start with Vega and Vega-C.
Okay, yeah. Those are the smaller ones, right? For lighter payloads.
Exactly. They handle the small to medium market. Vega started flying back in 2012.
Right.
It can lift about 1.5 tons to a 700-kilometer polar orbit. Good for Earth observation, science, satellites, that kind of thing. Then Vega-C came along in 2022. That had upgraded stages, including the P-120C, the P-160C's predecessor as its first stage.
And that gave it more lift.
Yeah, significantly more, up to around 2.3 tons.
Yeah.
A decent jump.
So wait, just to clarify, the sources focus on P-160C for Ariane 6 boosters. Does this P-160C development also mean upgrades are coming for Vega-C itself using this exact motor? Or is it more about the tech learned?
That's a really good question. So the P-160C, as it stands now, is primarily slated for the Ariane 6 boosters. It's designed for that scale. But the technology, the manufacturing techniques, the understanding gained from developing such a large, powerful, solid motor, that absolutely benefits the whole ecosystem.
I see. So lessons learned could trickle down.
Exactly. It paves the way for potential future evolutions of the Vega family, maybe even more capable versions down the line. The expertise doesn't just sit with one project.
Gotcha. So even if not directly using P-160C now, Vega benefits from the know-how. And these Vega rockets, they're important for, Europe's own launch capability.
Hugely important. They give Europe what's called independent access to space, especially for that booming small satellite market.
Right, that phrase independent access. Why is that independence such a big focus?
Well, it's about strategy and autonomy. It means Europe doesn't have to rely on, say, Russia or the US or others to launch its own crucial satellites.
Like for things like Copernicus, Earth observation.
Precisely. Copernicus, key scientific missions, commercial satellites. Being able to launch these yourself is fundamental. It supports Europe's tech leadership, its economy in the space sector. It's strategically vital.
And coordinating all this, making sure these big projects happen, that's ESA's job.
ESA is central. They manage these large, complex programs like the P160C development. It's their way of ensuring Europe stays competitive, stays self-reliant, and keeps pushing innovation in space.
So they're not just funding space telescopes, they're investing in the actual nuts and bolts, the rockets themselves, to make sure Europe has the capability.
Exactly right. Investing in foundational tech like this P160C has knock-on effects. It enables the science, enables the satellite services, and really strengthens Europe's overall position in the, global space economy.
Let's dive into the motor itself a bit more. You mentioned that carbon fiber casing. What other cool bits of tech are in the P160C?
Okay, yeah, the components are pretty amazing. That composite casing we talked about, Avio makes it in Italy. They use filament winding.
Like winding thread?
Sort of, yeah, but with super strong carbon fibers and epoxy resin wound incredibly precisely by automated machines. Creates that light but super strong shell.
Okay, cool. What about the pointy end, the nozzle?
The nozzle assembly. That comes from Ariane Group near Bordeaux in France. It's also made of advanced composites because, get this, it has to handle temperatures over 3,000 degrees Celsius.
3,000 degrees, that's insane.
It really is, and it's not just static. The nozzle actually pivots.
It moves, why?
For steering. That pivoting provides the in-flight directional control for the whole rocket booster. It's how you keep it on course.
Wow, okay. Steering with something enduring 3,000 degrees.
Yeah.
And how do you light the fuse on this thing? It must need a serious ignition system.
It does. That's the igniter system. Nammo in Norway builds that, under Avio's responsibility. It's made of a composite aluminum mix.
Composite aluminum.
Yeah, chosen for its ability to handle that initial intense burst of heat and pressure needed to reliably kickstart the main propellant burn. It's the matchstick, basically.
A very, very high-tech matchstick. So all these specialized parts get made in different places, Italy, France, Norway.
Right, and then the final steps, the integration of all these parts, and, crucially, loading the actual solid propellant that happens in French Guiana.
Close to the launch site.
Exactly. At dedicated facilities run by Europropulsion and Regulus, those joint ventures we mentioned earlier between Ariane Group and Avio.
It really shows the scale of collaboration needed for this kind of advanced technology.
Yeah.
And thinking about the timeline, you said the P120C only started flying relatively recently.
Yeah, it's quite impressive. The P120C entered service just 4 years ago, powering the first flights of Ariane 6 and Vega-C.
So going from that to successfully qualifying this bigger, more powerful P160C in just 4 years, that feels like a pretty quick pace of development.
It really does. It highlights that constant push within Europe to keep improving its launch capabilities, to not stand still.
So, summing that part up, the P160C is tested, it works, it's a significant step up in power. Europe's basically entering a new phase here, with more muscle for its space missions.
That's a great way to put it. It brings greater flexibility, better performance across the board. It means they can consider missions that maybe weren't feasible before, or launch existing types of missions more efficiently.
Like launching bigger science probes, maybe. Or more satellites at once.
Potentially, yes. Bigger probes to explore the solar system, or perhaps deploying larger constellations of satellites in a single go. It just opens up more options.
And for anyone listening whose interest is really piqued by all this space tech, you mentioned a resource.
Oh, right. Yeah, the SpaceInfo Club. It's worth checking out. They offer a bunch of free online courses.
Free courses? On what?
Pretty much everything space-related.
Yeah.
From, basic physics principles up to the business side of the space industry. Different levels, too, beginner to advanced.
And who teaches them?
They have guidance from experts around the world, people working in space companies. It seems like a really solid resource if you want to, dive deeper yourself.
Nice. We should mention the website. It's www.spaceinfo.club.
Yep, spaceinfo.club.
And you said it's free to join.
That's what our notes say, yeah. Free to sign up and access the courses. Definitely something to look into if this conversation sparked your curiosity.
Absolutely.
Okay, so let's try and pull this all together. The big picture, right? So fundamentally, this successful P160C test, it's a major milestone for Europe in space.
Hmm.
This upgraded motor is going to directly boost Ariane 6's performance, and the tech developed feeds into the potential future for launchers like Vega-C.
And that capability is key for Europe doing its own thing in space.
Exactly. It reinforces that independent access, lets Europe launch its own crucial science, Earth observation, and commercial satellites, and really solidifies its place in the global space economy. It's about capability and autonomy.
Okay, so it's a powerful new tool in Europe's space toolkit, which leads to a final thought, maybe something for you, the listener, to consider.
Yeah.
Well, thinking about these big jumps in rocket power like this P160C represents,
Mm-hmm.
what kind of future space projects do you think will benefit most? Where does this extra power and flexibility really open up exciting new doors? Is it bigger telescopes, missions further out, maybe more ambitious commercial stuff? What new possibilities does this make, well, more possible?
That's a great question to ponder. The sky isn't the limit anymore, is it?
Not even close. Lots to think about there.